We'll continue on the final exam review for MAT 0028. Problem 24 says simplify, and we have what's called a rational expression. To reduce this or simplify, we have to factor everything first so that we have products. So our numerator, we can factor. This is a difference of squares. It's two terms, it's minus, it's perfect squares. So it will be x plus 5, x minus 5. The denominator is going to be a trial and error factoring. There is no GCF. It's not a perfect square trinomial, so we're going to have to try trial and error. So I'm going to try it on the side. I want different signs. To get 2 here, I'm going to use 2 and 1 and split the x's. And for 5, I can use 1 and 5 or 5 and 1. So if I try 1 and 5, I check. Minus 10x plus 1x gives me minus 9. Almost works. I have the wrong sign. Remember, when that happens, all we're going to do is switch the signs. My plus should have been minus. My minus should have been plus. So 2x minus 1 and x plus 5 should work. We'll double check it. 10x on the outside minus 1x is 9x. So that works. So our factoring will be 2x minus 1 and x plus 5. Once you have it all factored, the new work is just to divide out common factors. So the pieces that are the same are the x plus 5. That's the part that can divide out. And I'm just going to erase this. So my answer will be x minus 5 over 2x minus 1. So we'll look at our answer choices since it's a multiple choice. And the choice is going to be A. B has signs wrong, and these aren't going to work. They crossed out before they factored. So choice is A. Problem 25 is a solve problem. So we have an equation. Even if it did not have the word solve, your equals tells you it's an equation. So you want to find out the answer for the x. Now we have learned a new kind of equation, quadratic equations, and that is actually what this one is because of the exponent of 2. Our technique that we learned for solving quadratic equations is to factor and use the zero product law. So we have to have a 0 on one side, which we have. We have to factor the other side into a product. So this is a trinomial. It's a simple trinomial because the coefficient of the first term is 1. So we can go ahead to our parentheses. So like a backwards FOIL, we're going to have different signs. We're going to split the x's. And we're multiplying to get 42. We're going to combine to get a 1 or minus 1. Our choice is going to be 6 and 7. Anytime you're going to combine to get a 1, it will be consecutive numbers, right? We want a minus 1, so we need that minus to go with the biggest one. So we want a minus 7 and a plus 6. We'll double check to make sure it's right. Minus 7x on the outside plus 6 will give us minus 1x for the middle. All right, so now we have it factored. We have our 0. We're ready to break it apart. This first piece is your A, so it is x plus 6 equals 0. The second piece is your B, x minus 7 is 0. And now we have linear equations where we just isolate the variable. So in the first one, we're going to subtract the 6, x equals negative 6. In the second one, we will add a 7, x equals 7. So we have two solutions. Normally we put these in solution set symbols, negative 6 and 7. I don't think the computer liked that very well on the MyMathLab. I think they wanted you just to write the x equals something. But the solution set symbols, that's the proper notation. Just to make the computer happy, we'll also do it this way. Problem 26 is another quadratic equation. It says solve, but the equals would also tell us solve. The exponent of 2 tells us it's a quadratic equation. So we make sure we have a 0 on one side. We need to factor on the other side. This one looks like a trial and error problem to do. So a little bit more difficult with the factoring. We will go ahead and try it. We want different signs. And to get 2, we're going to use 2 and 1. Split the x's. For 18, we can try 1 and 18, 2 and 9, 3 and 6, and then we have to flip them all over. And we're going to get some shortcut because of the common factors of 2 and 18. So anything that will put an even digit in that first parentheses is not going to work. So the 2 and 9 we can cross off. 6 and 3 and 18 and 1. All of those would get a common factor in the first set of parentheses. So let's try the 9 and 2. We check on the outside, minus 4x, inside, plus 9x. And this is going to work. So actually got the right one right away. So I can go ahead and split it apart. Either 2x plus 9 equals 0, or x minus 2 equals 0. Now it's a linear equation. Isolate your variables. So subtract your 9 from both sides. 2x equals negative 9. You are going to get a fraction on this one. Divide out your coefficient. So x equals negative 9 halves. For the other one, you're going to add your 2. X equals 2. So our solutions are negative 9 halves and 2. This was a multiple choice question, so now let's have a look at the answers. So we want a negative 9 halves and a 2. So our choice is going to be C. Next, we're going to simplify a radical. It says, assuming the variable represents a non-negative number, simplify completely. So we're going to break this down. I'm going to do it with the prime method. So we'll break 18 into primes. So we have 2 times 9, and 9 will break down to 3 times 3. And for your variable, you can write it out. So all of this is under your radical symbol. We will have 5 x's for x to the 5th. And it's a square root. So every time we find 2 copies of something we have a square, we can take one factor to the outside of the radical symbol. We can't do anything for the 2. There's only one copy. For the 3's, that's a square. 3 squared. 1 3 can go outside the radical. We're taking the square root of a square. So 1 3 goes to the outside. For the x's, every time you find a group of 2, 1 will go outside. So 1x goes out, and 1x for this group. And now we'll put it all back together. So on the outside of the radical, we have a 3. We have 2 x's, which we can write as x squared. Inside, we have left a 2 and an x. So we'll have a look at our choices. We have 3x squared on the outside. So our choice is going to be D. 2x on the inside, just to make sure. Our next problem is to subtract 2 radicals. To add or subtract radicals, you have to have like radicals. So right now these are not alike. They don't have the same thing underneath the radical symbol, but they're pretty big. So let's see if we can break them down first. So for 45, we could go with 5 times 9, and 9 will break on down, 2 3's. So we have 2 3's and a 5. To simplify that, we could take out a 3. That's a square. 1 3 on the outside, the 5 stays underneath. So that's simplified form for square root of 45. We'll work on 20. We could take 5 times 4, and 5 is a prime. 4 will go down to 2 times 2. So we have 2 times 2 times 5 underneath. The 2's give you a square. There's 2 of them. So 1 can go to the outside for that group. The 5 has to stay. Now these are like radicals. They both have 5 under the square root symbol. So you do your math with the numbers on the outside. So 3 minus 2 gives us 1. Keep 1 copy of the radical. 1 times the square root of 5, or just square root of 5. So looking at our choices, just the square root of 5 will be B.